Hey everyone, this is Dr. Clyde Letson, and today we will be exploring how a Leyden jar works, and we will be talking about how to construct a Leyden jar. So let's start first by talking about how to construct a Leyden jar. So a Leyden jar is very similar to a capacitor, and we'll talk about the capacitor in a minute. The Leyden jar is composed of two different types of conductors, one on the inside of the Leyden jar and one on the outside. For our construction, we will use, for our conductor on the inside, we will use water on the inside, which then has a piece of metal that is in the water and also projecting from the top of the Leyden jar. On the outside of the Leyden jar, we will use aluminum foil as our second conductor. Now the jar itself, we will use a old film canister made out of plastic. Now it's important that the jar itself is not made of metal. Okay, we can make the Leyden jar out of, for instance, plastic, like we said, or you can actually use a bottle. All right. So now, you remember I just mentioned that the Leyden jar is very similar to a capacitor. As a matter of fact, it was one of the first capacitors that were ever developed. If you're not familiar with what a capacitor is an electronic component that has the ability to store energy. Okay? So our electronic symbol for a capacitor is typically two vertical lines separated by some space with two lines going projecting from the sides of those two vertical lines. Now what they represent is the two vertical lines that are going down, again, are representing two metal plates. In the middle here of my capacitor, you'll notice I have a red square. What that represents is a dielectric that's in between these two metal plates. That dielectric is typically made out of mica, glass. It could be made out of paper. It could be made out of plastic. It can even be just a gap of air. Okay. Now, if we compare the capacitor to our Leyden jar, this plate over here will be equivalent to our water that's on the inside, our conductor that's on the inside. So this metal plate for capacitor is similar to our water that's on the inside, and this plate on the other side here is similar to our aluminum that's on the outside of our Leyden jar. Now the actual jar itself, which for us in our case is plastic, is actually our dielectric that's in the middle. Okay, and the metal that's actually sticking into the water here represents this line here that is connected to this plate. Now, if we want to, we didn't mention anything about connecting a wire to our aluminum, but if we want to, we can actually connect a piece of wire to our aluminum to represent this piece here of the capacitor. Now, let's talk about charging up a capacitor. When we charge up a capacitor, what we're doing is we can either be introducing electrons into the inside of the capacitor, or we can be removing electrons from the inside of the capacitor. One good way to charge a Leyden jar is to use a electrophorus, which I have videos on my YouTube channel that talk about electrophoruses. We can use an electrophorus to charge up a capacitor, pardon me. Okay, what happens in the case that's demonstrated here, when we charge up this Leyden jar, what happens is we're introducing negative charges into the water, or onto, which will be similar to introducing negative charges onto this plate or this side of the capacitor. All right, now when we introduce that onto this side, the outside at the same time needs to be grounded as we're introducing the electrons into the Leyden jar. One way that we can ground the outside is by simply holding the Leyden jar, pardon me, in your hand. What that would allow now, as we introduce the electrons here, the negative charges that are in the aluminum are going to rush towards the outside. And because you're holding it, those negative charges are actually going to go through you, leaving us with more of a positive outside. The electrons on the outside, or pardon me, the atoms on the outside will be more positively charged, and therefore creating an electric field between the aluminum and the water that's on the inside. Similarly, for a capacitor, when we charge up the plates on one side here, the electrons that are on the metal, that are in the metal, on the other side try to get as far away from those negative charges, because of course like charges repel. And so when that occurs, then it leaves the atoms that are on the opposite side of the capacitor to become more positively charged, creating an electric field within the dielectric. All right. And so when that happens, then your Leyden jar becomes charged. Now, if you want to discharge the Leyden jar, you pretty much have to repeat the process in the reverse, if you will, and make sure that you're holding the aluminum on the outside here with one hand, and then you touch the metal here on the other side with your other hand. What that allows then is for the electrons that are inside of the Leyden jar to now go through you and use you sort of like a resistor, okay, and use you to now reintroduce electrons to the atoms that are on the outside here, therefore bringing the entire Leyden jar back to being neutral. Okay, and that's similar to what happens with a capacitor. If you want to discharge the capacitor, what you can do is you can actually connect this lead of the capacitor to this lead of the capacitor, and what would happen is the electrons from on this side will then go over to the other side and recombine in order to balance everything out. So that's how our Leyden jar in our experiment is going to work. If you have any questions, you can post comments. You can also subscribe to my YouTube channel, or if you want more information about me, you can visit my website. Hope to see you guys on my channel in the future.